Hello everyone, my name is Casey and welcome to the introduction video for the Organic Chemistry 1 course. Before we get started, the reference material or the textbook that what I'm going to be showing you guys comes from, and in the next videos as well, will be from Organic Chemistry 8th edition by Francis A. Carey, in case you want to just know exactly if you have the same source or not. So for the first video, we're just going to be looking at the difference between structural formula and bond line formula. It's a very important concept to understand, even if you're not in Organic Chemistry 1, but you want to take it in the future. It's important to know the difference between these two things. So I'm going to just draw out some basic structures. We're not going to get into naming right now, and I'm just going to show you how they look in each one, because you might be asked to put structural formula or bond line formula on your test, or both, and you're going to want to know exactly what the teacher's asking. So I'm still trying to get used to this stylus pad, so please excuse the childish looking writing that I'm going to be doing right now. So if we're going to draw out something, let's just draw out this right here. CH3, CH2, CH2, CH3, which would also be known as butane, but we're not going to get started with names right now. You can see for the structural formula, we're actually writing out the letters. We're actually writing out each individual part of it. We're not going to be simplifying it. It's technically the longer way of doing it. It works, but there is a condensed way of doing it, which is bond line. So you see right now we have groups like this, and if we want to just draw it out to see exactly what this looks like, because this might be the first time you're looking at something this complex, it would look something like this. Let's just draw it out. You can see we have 3 hydrogens on the end carbons and 2 hydrogens on the middle carbon, because carbon can only form 4 bonds. So you can assume where there's no carbons attached, you can put a hydrogen, unless you have another functional group, which we'll look at in a second. So this is what we have right now, but drawing this takes a while. We don't really want to do that. So what we're going to be doing is we're going to be using lines. You use a line like this. Now when you see a line like this, it indicates a bond between a carbon and a carbon. So right over here you'll have one carbon, and right over here you'll have another carbon. Let's get that off the screen. So each end of the stick is going to be a carbon. So we're going to just draw the bond line first, and I'll show you exactly what everything means. For the butane, the CH3, CH2, CH2, CH3 that we drew, we're going to have this right over here. Now, you're going to want to just look, see, you have, can we use a different color? Yeah, let's change. What do we want to use here? Let's use this nice bright blue. Right over here, that'll be carbon number 1. It'll be this guy over here. Right over here will be carbon number 2. It will be this guy over here. Right over here, carbon number 3, this one. And finally, on the other end, we'll have carbon number 4. So that's the basic premise of bond line. You're only going to be showing carbon and the functional groups, and we'll go to functional groups in a second. You may be wondering, where are the hydrogens? You have to imagine the hydrogens. You don't draw them on, because like over here, it takes way too long to actually draw all that. So if you want to imagine the hydrogens, remember that carbon can only form 4 bonds. So if we want to look at it like this, we can draw our hydrogens. This carbon can have 3 hydrogens. This carbon can have 3 hydrogens. And these 2 in the middle can have 2 hydrogens, because they're already attached to 2 carbons. So that's the bigger blown up structure of this, but we're only going to be showing this middle thing right here. That's what bond line formula is. Now you might ask, what happens when we get something attached to it that isn't a carbon and isn't a hydrogen? So for example, a hydroxide group, which will also be OH group, a hydroxyl group, whatever you want to call it. This, and we have an OH group attached, it's going to be forming an alcohol. So we're going to have another video on alcohols later on, but what if we had this right over here? CH3, CH2, CH2, OH. Now you see we do have our 3 carbons, which you'll know probably by now how to turn that into bond line, but we have OH right over here. So how would we transform that into bond line? Now there's one thing you're going to need to take into consideration when drawing it. So we're going to draw it out right now. All right, now the thing that people get confused off, and I can personally say I got confused with, is that this last branch over here, where you have this one right over here. This end over here where the OH is not representing a new carbon. It is representing the OH. So if we wanted to count our carbons and match them up to this over here, this would be the end carbon, which is the CH3. There'd be 3 hydrogens attached to this. This would be a middle carbon. It'll be this one right over here. This would be another middle carbon right over here. And this end right over here is not a carbon. It is representing the OH hydroxyl group right there. So, just make sure, you do a whole branch right over here, but you don't want to confuse that with another carbon, because, you can automatically assume this is a butane with an OH group, so butanol, but it's actually propanol because there's only 3 carbons. If you want to make sure you avoid this mistake, a little trick that I decided to do just to help me, let's go down a little bit here. Right over here. Rather than drawing the full, the full length branch for the OH group right over here, just draw a very small extension branch, right like that. Your teacher won't take off marks, don't worry about it. And that just, it helps you think, okay, that's not a full branch, let's not regard it as a full branch. And you're not going to think that it's a bond between a carbon and a carbon. I'm not saying the bond length is smaller, we're not going to go into that kind of detail. Just for visual purposes, you can see that carbon number 1, carbon number 2, carbon number 3, and no carbon number 4. So it's just one little extra thing to take into consideration. Let's look at one more structure. We're going to look at a ring structure right now. Let's look at, here we go. Okay, so we're going to, let's draw this out. We're going to have CH2, CH2. Let's do another, let's keep going. I'm going to add a chlorine group. Sorry, chloride group. I always get that mixed up. You see, let's put that in a different color. What do we want? Want yellow? Let's go with yellow right there. So that's a really ugly yellow. That's nice. All right, there we go. So this is our new structure right over here. It's a ring. Now, you're going to obviously encounter some rings in organic chemistry, and the naming is a bit different, but we're not going to look at the naming right now. We really want to look at the structure. Same concept applies. It might look a little different, but, you see this carbon over here, it's attached to 2 other carbons. So when we fill it up with hydrogens, obviously it can only form 4 bonds. We're going to fill it up to have 2 hydrogens. So we have 2 hydrogens, 2 carbons, 4 bonds. Now, drawing the structure is, we're going to take into the same rules. Number 1, this functional group, this non-carbon, non-hydrogen group, we're going to need to show it. And everything else, we're going to just turn it into a line. So let's start off with these 2 CH2 groups. We can represent it by that line right over there. Now we're going to go expanding around the hexagon. And now we have accounted for this carbon, this carbon, this carbon, this carbon, this carbon, and finally this carbon right over here. There's 6 carbons in the ring. It's a hexagon. Now we have 2 other things over here. We have another CH3, a methyl group, and we have a Cl, a chloride. It's a halide attached to it. So we'll start off with the CH3 methyl group, and we're going to add a branch right over here, and that little line sticking out will represent the CH3 just like that. But obviously, since we have a non-carbon, non-hydrogen group over here, we cannot just simply add a line out and just pretend people know what's up. We have to do the, actually write Cl into the bond line formula. Now we can take into the same trick like last time by putting a not so extended line, and we can write Cl, or you can do a full line. It all depends on how well you can differentiate the 2 things, just so you don't get confused. But right there, that is the bond line representation for this group right over here. Let's do a nice little arrow, and you can see we can account for all the carbons. We have we're not gonna do the proper numbering right now. I'm just gonna count with you. 1, 2, 3, 4, 5, and 6. Carbons, those are the ones in the ring. We have 1, 2, 3, 4, 5, and 6. We have this outer carbon right over here, which is represented by this end of the line right there. And then we have our chlorine, which is right over here. So our chloride ion. So it's not an ion, it's technically attached. So that is the bond line representation of this over here. And if we want to go back up to look at what we've done before, we pretty much cover the basic, things that you can encounter that might trick you up. It's really when to get into the functional groups, the standard line, something like this, it's pretty standard. You're going to learn that within probably your first or second class after you review some stuff from general chemistry. But, it doesn't get that confusing. When you get into double bonds and triple bonds, you do get to get some different things, but I'm not going to introduce those right now. We need to really learn what the purpose is and what the properties of the double and triple bonds are before we get into it. We're going to look at a bit of naming in the next video, so we can look a bit more into how we name just by looking at bond line and how we name with structural formula and trying to find an easy way to compromise between the two, because you can't always go back to structural formula. You do need to start getting into understanding bond line, because structural formula takes a while to write, and your teachers will think you're not understanding the material to the full extent and might actually take off marks depending on who you have. So thank you very much for watching. This was the first video, and I'm going to be putting up some more to cover later parts of the video. So thank you very much for watching, and have a great day.